In this video, we are going to create a full-stack Vue.js app with Vue.js on the front end, Node.js on the back end, PostgreSQL Database, and we're going to use TSX to run TypeScript in Node.js, Express for all the web routes, and Remult to handle all the data transfer back and forth. We're going to use server-side paging, sorting, and filtering, full create, update, delete capabilities, real-time live queries, validations, updating multiple rows, moving logic to the server, Authentication, Authorization, of course Postgres database, and eventually we'll even deploy to the cloud on Railway. So let's get started. The first thing I want to do is create a Vue.js project. So I'm going to do npm init vue latest. I select the project name, and I want to use TypeScript, and for everything else I'm going to answer no. Next, I'll change directory to the directory that it's created and open Visual Studio Code. Here we can see the standard solution created by Vite. And the first thing we need to do is npm I to install all the required packages for this project. Now that it's done, let's go ahead and run npm run dev, which will launch the Vite dev server. And when I see this screen over here, I can press O, and it will open the web browser with the Vite project we've created. Great. Now let's go ahead and start building the backend. I'm going to need to install a few packages. So I'm going to install Express for the web routes, TSX to run TypeScript in Node.js, and Remult to handle all the CRUD capabilities. I'm also going to install the types required for Express on the dev dependencies. That's because we want to use TypeScript on the backend and we want to have the Express types. Now let's go ahead and start adding our server. I'm going to go to source and I'm going to create a server folder and in it an index ts file. And then I'm going to define a standard Express application and tell it to listen on port 3002 and console log started. So that's our basic Express server. Let's add a script to run it. So I'm going to add a dev node script that's going to say tsx watch source server. So this tells tsx to run node with support to TypeScript. When I say watch, it will refresh on every change that I make to the code. And source server tells it where it needs to find the source code, which is the index file here on the server. Let's save this and run this. And we can see that it started and it console logged the text that we've written. Let's go ahead and add a smiley over here to see that it works. And it does. Now let's add a basic route. I'm going to say API hi. Let's get a request and a response, and I'm going to ask it to respond with hello. Let's go ahead and test that. I'm going to go to localhost 3002 API hi. And we get to see this hello. So great, now we have two dev servers. We have the Vite dev server that is used to develop Vite and get the hot reload when I'm making changes in Vue, actually. And we have the API server that we're going to use to serve us with the API. Now, I don't want to use two servers or have complex URLs for all my API calls. I want my URLs to be relative. I want to say something like /API/hi and then get the results for my Node.js server. To do that, I can configure the proxy of Vite to proxy every call that is made to the API and send it to our server. So let me show you how it's done. I'm going to add a server setting here, and I'm going to add a proxy. And then I'm going to say that anything that reaches API should go to HTTP localhost 3002. So as soon as I do that, the browser refreshed and now calls API/hi. So Vite gets the request, uses this proxy, and sends it to our Node.js server. Great, so we have everything set up, and it's time to start building our application. And the first thing I want to do is I want to create, we're going to write a to-do application, and the basic part of a to-do application is something called a task entity. So let's go ahead and create that. I'm going to define a shared folder, and in it I'm going to put a type called task.ts. And I'm going to say export class task that should have an ID, a title, and a completed indication. And this type is placed in the shared folder so that I can share it both on the front end and the back end. Now, I want to use this type as the single source of truth of everything that revolves around task. And that's what where Remult comes in. I'm going to give it the entity decorator from Remult. I'm going to name it tasks, and I'm going to ask Remult to allow API CRUD. This will tell Remult to actually expose full CRUD capabilities to the API. Later we'll restrict that a little bit, but this is a good place to start. Note that I'm getting an error for tasks telling me that I should have experimental decorators set to on. I can click quick fix and it will add it to my tsconfig. So we can see the tsconfig over here with the experimental decorator. And as soon as I save it, the error would go away. Next, I'm going to get each type and tell it what is its role. So ID is going to be an auto increment. I can also use UUID or CUID, but auto increment is good enough for what I want right now. A string field and a Boolean field. Okay, so by providing Remult with these decorators, I'm actually instructing it how to store this in the database, how to expose it on the API, how to use it in the front-end query language. All of that will be derived by these several decorators. Let's go ahead and define that in the API. So I'm going to go to server, and I'm going to add an API TS file. And I'm going to say export const API equals Remult Express. And let's import it first. Remult Express from Remult/Remult Express. And I'm going to send it to its entities array. I'm going to send the task that we've defined. Later, when we'll have more entities, we'll put them in this array. Now, the last thing I want to do is tell Express to use our API. And as soon as I do that, we get a new /API/task route that will bring back all the tasks in our database. So let's do /API/tasks, and we can see that we're getting an empty array. Let's go ahead and do that with a Thunder client, which is a kind of a Postman equivalent within Visual Studio Code. And I'm getting an empty array, and I can actually post items here. So I'm going to post an item with the title of clean car, and it will add it to my database. Now you might ask, what database am I using? And at this early stage I haven't defined any database, so by default it's using a very basic JSON-DB that's defined over here. Later in this tutorial we're going to change it to use Postgres, but you can use any database you want. Mongo, MySQL, even SQL Server and Oracle, really any database you can think of. So let's go ahead and add a few more tasks. So I want to have read a book, and I want to have take a nap. And I'm going to set it completed to true. And we can see that it was set to true. And when I press get here, I'll get these 3 tasks. And let's add another 2. Pay bills. And I haven't done that. And do laundry. And you can see that it's all saved in our database, and if I refresh it, I'll get them all on the API endpoint. Great. Now let's go ahead and use these same tasks from the front end. So I'm going to go to my app.view, and I'm going to first of all clean house here. So I'm going to delete the existing template and delete the styles that I don't need. And in these imports, I'm going to say ref or const tasks equals ref. And I'm going to get ref from view of a task array and initialize it with an empty array. Okay, and I'm going to say import task. Yeah, I want to keep it like that because later I'm going to do whatever I want with it. So now our app looks like this, and I can say, yeah, okay, it wants me to say here, it wants to say input type. So for now, I'll give it to them. Later, I'll change that. On my HTML, I'm going to say h1 to-dos, and I'm going to say div v4 task in tasks, and I'm going to give it an input with a type checkbox, so it would look like a checklist, with a model of task.completed, and task title over here. Great. Now that we have this set up, let's go ahead and get data from the backend. So the first thing I want to do, I'm going to say const task repo equals Remult repo of task. That tells Remult to go ahead and return me a repository of type task. And I'm going to use that repository to do anything that is task related. I'm going to use it to get data from the backend, to write data to the backend, delete items, everything that's related to task is going to be covered by this repository. So when the component mounts, I want to say task repo find then tasks.value equals items. Okay, so the first method of repository that I'm using is called find, and it's used to get data from the server from the API. So let's save it, and we can see the tasks over here. Let's check out the network tab, and we can see that we're making standard API calls, simple GET requests to get the items from the server. Now by default, find returns all the items, but of course I can limit it to say, hey, bring me only 2 and page 2. So it's going to bring me the second page, and we can see how it's all a standard REST API calls to go ahead and get that. I can say order by completed ascending on the backend and descending. So the data comes sorted all the way from the database through the REST API and to my front-end code. I can say where completed is true or false to filter the data. And of course, this is type safe. So if I say completed true, I will get an error saying it's not the right type. And if I set it to undefined, it will actually ignore the filter, which is kind of useful in lots of cases. So here we go. Just by defining our task and registering it on our API, we were able to get full stack capabilities around these tasks, including server-side sorting, paging, filtering, storage, and much, much more. So let's start preparing this a bit further. I want to set up here a main area. So the list will be in some kind of container. I'm going to also create here a form with an input, with a placeholder of what needs to be done, and a button that will add a task. Cool. And now let's go ahead and give it some CSS so it will look nicer before we move much forward. So I'm going to go to assets and to my main CSS, and I'm going to start by deleting it. And then let's start styling. I'm going to say font family is Arial, background color white smoke, and margin 0. And then I'm going to style h1 and say that it has a color of EF4444. It's a nice shade of red that I like. Font style italic. Font size 3.5 rem. Great. Font weight inherit. Text align center, and margin 0. Much better. And let's style our main area. I'm going to say background color white. I'm going to say border 1 pixel solid light gray. I'm going to say max width 500 and margin auto. So it's in the middle. I'm going to say border radius 0.5 rem. And I'm going to give it a bit of a shadow. So I'm going to say box shadow 0, 2 pixel, 4 pixel, 3, and 25 pixel, 50 pixel, and this nice shade of gray. Great. I think I want to have one more 0 over here. No. Yeah? Yeah, I'm missing a 0 over here. It's too dark. Okay, great. So now I have my shadow. Let's style the items in this main area. So I'm going to say main div and also main form. And I'm going to ask it to have a padding of 0.5 rem. I'm going to add a border bottom. So I'm going to have a separator solid light gray. And I'm also going to say display flex, align items center, and gap 25 rem. Great. Now let's go ahead and format our inputs. I'm going to say input font size 100% because I don't like that the inputs are smaller. I'm going to say padding 8 pixels, so it's going to have some meat on it, and border 0, and width 100%. Okay, and let's go ahead and fix the checkbox. Width 1.5 RAM, and height 1.5 RAM, and flex shrink 0. Great, so we have better checkboxes. And also I want to say that the placeholder should have a text style of italic, or font style italic. Yeah, I like that better. And the last thing I want to format is our button. So I'm going to go ahead and grab our button and say that the background color is white, that the border color is this shade, that the padding is 0.5 RAM, and border radius of 0.5 RAM as well, and font size inherit, or 100%. Great. And white space no wrap, because I don't want to have line breaks within my button, and eventually cursor pointers that will have this nice little indication here. Great. So now that we're done typing some CSS, let's go back to doing actual important stuff. Let's go ahead and take care of adding, removing, and editing existing tasks. So the first thing I want to do is be able to add a new task, and we have the form here with the input and button. So let's go ahead and add a ref and saying const new task title ref empty string, and also we're going to add an async function add task that will first of all try and catch and handle errors. Any errors that should come, I want to show it as an alert. And in my actual code, I'm going to say const new task equals await task repo insert a task where the title is this new task title value. So this will insert a new task and return it to the new task object, and then I'm going to say this those tasks dot value without this push new task. And I'm also going to say that new task title dot value should be set to blank, so I can immediately enter a new task. Let's bind this to our HTML. So I'm going to say here v model equals new task title, and for the button I'm going to say, actually for the form I'm going to say submit add task, and I'm going to also say here dot prevent, so I will not get the form default behavior. Now let's add a new task, and we see that a post call was made to the backend with the new task that we've created. And we can actually look at our JSON database and see that the task is already in our database. And I can say here another new task, and we can see that it's immediately added over here. Okay, so by using the repo insert, I'm able to add tasks to the backend in a fully typed manner. So if I give it a wrong name, I will get an error. So I'll get type safety for the same type definition for both front-end and backend. Let's add the ability to delete a task. So I'm going to say async function delete task. I'm going to get a task as a parameter, and try catch alert error message. Great. And I'm going to say await task repo delete of task. And once deleted, I'm going to go to our tasks array and filter it to only bring me tasks that are different from the current task that I've just deleted. Now let's go ahead and add a button at the bottom. I'm going to go here and add a button, delete, and on click delete task with the task as a parameter. So now I have this delete button, and when I click it, there's a delete API call that's being made, and the data gets removed from the database. And again, we can look at our database, and as I click delete, we can see that the data is removed. Let's go ahead and save changes. So I'm going to do async function save task. And just like before, try, catch, alert, error message, and await task repo save of task. And we can call it on any change of our checkbox. Let's see that it works. Great. You can also again look at our database and see that it refreshes. And we can also allow editing of the task title. Task title. And add a button to save, saying click save task. So I can change some values, save them. Again, a put call will be made to the backend, and we can see the data saved in our test.json, and I can fix it and save it again. Great. So just by defining our tasks, we got full stack query language and CRUD capabilities with this simple definition of our task. Let's see what else we have on inline to do today. So we have done server-side serving, paging, and filtering. We got full CRUD capabilities. Now let's talk about real-time. So our users like our app so much that they gave it to another user. And that as a user went into the app and start ticking tasks. But the first user couldn't see those changes until they've refreshed the browser. Let's go ahead and implement these functionalities that both users will always be up to date. So let's switch back to our app.view, and instead of using find over here, and then we're going to use live query and subscribe. And subscribe gets back an info object that I can use to apply changes on my tasks.value. So now whenever a change is made on the backend, I'm going to subscribe to it and I'm going to get the changes and apply them to my list of tasks. I also want to on mount. I want to register the return value of subscribe to the on_mount method, so it will be automatically unsubscribed when the component unloads. Let's save and see how this works. Now I have both tabs over here, and we can see that any change that I make immediately reflects in both browsers. Now you may wonder how it works, and it's actually just an implementation detail. By default, we are using, let's clear the network tab and see, we've defined a stream over here, which is an HTTP server event. It's a very standard, very basic way of sending messages from the backend to the front end. And you can see that whenever I tick a box, a message gets sent and update the other UI. Now the server sent events that we're using here are great for development and great for up to 200 users. But then if you need to scale above that, it's just as easy. You can replace it with WebSockets or with Ably or PubNub, which are industry standard robust tools. And all you need to do is replace a plugin to get those to work. So your code essentially doesn't change, just a few endpoints and plugins, and you can find articles of that on our website. So great, now our application is immediately responsive, but we actually added a bug. Because if I add a new task, we can see that it's added twice to my list and only once to someone else. And that happens because when I add a task, I get a message to add a task, and then it's added. But I also added the task manually in this line of code over here. When we're using a live query, we no longer need to worry about the state ourselves. So I can remove this line and also remove the lines that happens in delete. And now everything will work as expected. Great. Cool. So we've implemented live queries. The next thing I want to discuss is input validation, is user input validation. Currently, our user can simply add empty task, and we want to prevent that. Now, that's one of those concerns that always gets confusing when you're working on a full-stack application. You need to implement front-end validation to get a good user experience, and back-end validation to get a consistent API operations. And a lot of times, those don't match. With Remult, you define those validations in a single source of truth. So if I want the title to be required, all I need to say here is that I validate it using the validators required. And as soon as I do that, the user cannot add an empty task. Now if I clear the network tab and click it again, you can see that no network calls have been made. This is front-end validation. So let's bypass it. Let's go ahead to our request and try to send a request with an empty title. And we can see that we get the same validation error also when you are calling it through the backend. So we're getting consistent validation code between the front end and the backend. And this can be any kind of validation. You don't have to use built-in validations. I'm going to switch over here to our task.ts, and instead of using this built-in validation, I'm going to create a new arrow function saying task if task.title length is less than 3, throw arrow to short. And now this very custom validation will happen in the front end and will also happen when I'm making an API call on the backend. Notice that I'm also getting here the error per field that I'm using. So if I had like 100 fields and a form with 100 inputs, I can place the correct error next to the correct field and give my user a great user experience. And again, all of that by saving the single source of truth in our task.ts. So let's delete these empty ones that we don't need. And we reline. Perfect. Next, our users like the application, but now they're getting greedy and they want me to click all of these items just as once. They're coming from a user perspective and saying, sometimes I don't have the patience to go ahead and click them all. So as a good UX developer, I'm going to go and give them what they want. I'm going to go to app view and I'm going to add a function. I'm going to call it set all completed. It's going to get a completed parameter which is of type boolean. And then I'm going to iterate all the tasks from the backend. I'm iterating the task from the backend because maybe my local state only has part of the rows, has filters, paging, or whatever. And here I'm going to say task repo save the current value from the task and the new completed value. And let's go ahead and add a button here. It's going to call our method. And let's create another one that will say uncompleted, and we're going to call it with false. Great. So now I can click set all completed and it will set them all to completed, or set all uncompleted and they will all be uncompleted. So I'm happy, my user is happy, but my boss not so much. My boss takes a look at the network tab and says, hey, can you see how many requests are you making? You're making a request per task. Imagine if you have 1,000 tasks or 10,000 tasks, what would you do then? So that's one of the fun parts about Remult. Because we're using the repository to interact with the task, it's very easy to migrate code from the front end to the back end and vice versa. So let's go and move this code, this set all completed function, to the back end. So I'm going to add a new item here and I'm going to call it tasks controller and give it a class name. And then I'm going to go to the front end and copy the set all completed function and place it in our class. And I'm going to make it static and no longer a function. It became a static method. And I'm going to decorate it with the backend method decorator. Now the backend method decorator tells Remult that whenever you're about to call this method, instead of running it on the front end, make an API call to the backend and run it there. And now, just like before, I'm going to define the task repo, which is going to be of type Remult repo task. And that will bring me, just like before, a repository of type task. But previously, the repositories that I've got on the front end made API calls to the backend. Now that I'm running on the backend, within the backend method, I'm going to get a repository that updates the database directly. Now let's go ahead and register it on our API. So I'm going to add here the controllers array and register this controller. And on the front end, instead of doing this for loop, I'm going to say await task controller set all completed with the parameters that I've got. Now, if I clear the network tab, I'll call set all completed. We can see that a single API call is being made to the backend, and this entire logic runs on the backend. And another nice side effect of using the same code base for both frontend and backend is that if I'm going to change this to an invalid type, if I make an error when I try to call the backend, the code keeps me safe, and TypeScript lets me know when I'm doing such errors. Cool. So we've done all of that, and the next part of our list is authentication. As our application evolves, not anyone is allowed to see the test. No, we need to be specific about it. We actually want our user to be authenticated before they can see any one of our tasks. And just like anything else, I want to define it in my single source of truth, in my task. So let's go ahead and say here, allow authenticated. And as soon as I do that, if I try to refresh the page, we can see that I can't get the data anymore. I get a forbidden error because I'm not allowed to see it since I'm not yet authenticated. And if I want the same behavior for my backend method, I'll go to my task controller and say here just as well, allow authenticated. And now they will also bring back a forbidden error. Now, authentication itself is a concern that's been solved many times, and you can solve it in any way you really like. All you need to do is tell Remult who is the current user using the app. So there's just one place where you need to adjust it. But for the sake of this demo, I'm going to use a very basic cookie session authentication. But of course, you can use really anything. So let's go ahead and implement Node.js basic authentication. I'm going to start by installing the cookie session. The cookie session package handles a session within a cookie, as it sounds. And I'm also going to install its types, so I can use it in TypeScript. And I'm going to go to our server and import it and initialize it. Secret. Later we're going to put something more robust over here. Now let's start implementing the sign in and sign out functionality. So I'm going to add a new file called auth.tf, and I'm going to have a valid users list. It's going to be of type user info, and I'm going to have two users. One is going to be called Jane, and another is going to be called Steve. Now, of course, this is a very basic static list. In real life, you're going to use a database or an external provider such as GitHub or Google or Facebook. I'm also going to define an auth route, express route, and I'm going to register it on our express. I'm going to say here app use auth. I'm going to ask the auth to support JSON. And then I'm going to add a normal express route /API/sign-in. Now, of course, I could have used backend method for this, but one of the things that I want to show is that Remult can work with existing projects, and you can use existing routes with it. You're not forced to use backend method if you don't want them. You can use whatever you want when you want it. So I'm going to start by finding the user. Username equals rec body username. And if I found the user, I want to set the session user parameter to the users that I found. And I'm going to send to the respond as JSON the found user. And if it fails, I want to send to the respond a status of 404 because I couldn't find it, and give it a JSON of invalid user. So that's our sign-in functionality on the backend. Now let's go to the front end and add an auth component. So in auth view, it's going to have a script with a lang of TypeScript, and it's going to have a const username equals ref blank, and it's going to have a template. And let's start with that template showing us the app view. Start very, very basic. Now in the main TSX, I want to replace this. Instead of running app, I want it to run auth from our auth component. Great, so it looks the same. And now let's go ahead and say const signed in equals ref false. And I'm going to say that I have a div that should only show up if signed in. So now we shouldn't see the app anymore. And then I'm going to have another div with v else. And here I'm going to say h1 to-dos, and a main, and a form, and an input with a model of username, and a button of sign in. And I'm also going to put a placeholder here saying username, try Jane or Steve. Great. And I'm going to need an async function sign in that is going to define a result and make a fetch call to the backend. Now again, I could have used backend methods, but I want to show that I can use also anything else. So method post headers content type application JSON and body JSON stringify username.value. Now if the result is okay, then I want to say remult.user is the user that I got from the result, and signed in equals to true. Else I'm going to give an alert with the result that we got in JSON. So that's our sign in method. Let's go ahead and call it when we submit the form. Sign in, and I also want to do here prevent default. Great. So let's show you sign in with an empty user, an invalid user. Invalid user is also invalid, but if I sign in with Steve, I get to sign in, but I still don't see my data. And that's because we've implemented sign in, and we've told Remult on the front end who the user is, but we haven't told Remult on the back end who the user is. So let's go ahead and do that. I'm going to go to server API. Actually, I want it to be API TS and not TISX. I'm surprised that it worked, but it did. Cool. So API TS. And I'm going to say here, get user. So whenever Remult needs to get a user, it gets a request object. And just like before, I'm going to go to the session user member. So that's where Remult gets the user, because the user is stored in the session. And now as soon as I save that and refresh, if I sign in as Jane, I'll get to see my data, because now I got the user from the session info and my data is okay. Now, if you have a few more things to do about implementing a simple sign in, sign out state mechanism, first thing we need to do is when we refresh to have the correct user. The user is currently only stored on the backend on the cookie, so we need to ask the cookie on the backend who is the current user. So let's go ahead and do that. I'm going to go to auth and I'm going to say auth.get API current user. It's going to get a request and a response, and it's going to write to the response the request session user. And on the auth.tsx on the front end, on the auth view on the front end, I'm going to say something like on mounted async, and I'm going to say here a const result equals await fetch /API /current user, and I'm going to say remult.user equals await result.json, because we're going to get the result as JSON and extract it, and we're going to say signed in is equal to remult authenticated, so only if the authentication is correct. And great, now we get the session from the cookie and we can see it over here. Let's also add some sign out functionality. So I'm going to say over here, hello Remult user name, so we can see the current user, and have a button here saying sign out, and it's going to do a click sign out, and I'm going to add this function here. And it's also going to await a fetch /API /sign out, but this time we're going to use post. And then it's going to set remult.user to undefined and signed in to false. That's on the front end. And on the back end, we're going to say auth.post API sign out rec res, and it's going to take the rec session user and set it to null, and it's going to send the response a JSON of signed out. Okay, so now if we click sign out, we actually sign out, and if we click sign in, we are signed in. So we've officially completed the sign in, sign out mechanism that has nothing to do with Remult, but we were able to leverage it in Remult by setting the user over here for the backend and setting the user over here on the front end. And that way we can use Remult on both front end and backend when we know that we have the correct user. So we've implemented authentication, but let's take this one step further. Let's say that not all users are equals. A user that can add and delete a task should be only an admin. So just like anything else, I want to set it on my single source of truth, on my task.ts. So I'm going to say over here that if someone wants to delete, they should be an admin. And if someone wants to insert, they should be an admin as well. And as soon as I do that, if I try to add a task, I'll get a forbidden error. If I try to delete a task, I'll get a forbidden error. And it's because I haven't set anyone to be an admin. So let's go ahead and give Jane the admin privileges. And now that Jane is an admin, Jane can add a new task and can delete a new task, whereas Steve cannot. Great. So that's how easy it is to set authentication and authorization. But I want to do one more thing. I want to have a consistent user experience that the rules that governs the API will also govern the UI. So if a user cannot delete, he shouldn't see the delete button. And if a user cannot add, he shouldn't see the add form. And I want to do that using the same settings. I don't want to have to duplicate this logic. I want to use the same settings that I've set over here and reuse that also on the front end. So let me show you how I do that. I'm going to go to my app.vue, and I'm going to say here on the form, only to show it if the task repo metadata insert is allowed. So only show the form if insert is allowed. And as soon as I save that, you see we cannot longer add. And let's do the same for the delete button. So I want to show the delete button only if task repo metadata delete is allowed. And once I do that, the delete button is removed. So Steve can no longer see the add and delete functionality. And if I for some reason change this code and refresh my browser, it will reflect immediately. That's because it is all controlled by this single source of truth. So we've implemented authentication and we've implemented authorization, and it's time to grow up and use a real database. So let's go ahead and install a Postgres client. IPG. Now, of course, I can use any database I want. I can use Postgres, Mongo, MySQL, SQL Server even, but for this demo, I'm going to use Postgres. And to use it, all I need to do is on my API TS, import Remult Postgres, and say that the data provider for my API is a Postgres connection. And I'm going to use the connection strings that I've prepared in advance. So as soon as I set it over here, you will see that the server is started and added the table itself. By default, Remult has an ensure schema mechanism that checks if the table exists in the database, and if it doesn't, it creates it. And it checks for every column if the column exists in the database, and if it doesn't, it automatically adds it. Of course, you can disable that by saying ensure schema false, and you can add whatever migration path you want in terms of database migrations, but this is a very simple mechanism that works pretty well and scales up pretty well, in my opinion. Anyhow, now that we have the database, let's sign out, sign in as Jane, and add a wash car task. And now that we've added it, it's here, and we can see that if two users are looking at it, both of them are setting it, and we can actually go to our database and check out the task table and see that we have the data in our database. Perfect. So now let's start getting ready for deployment. Okay, we've completed the Postgres database and we should start working on deployment. The first thing I want to do is I want my API server to also serve my Vue.js files. I don't want to have two servers and I want to have complexities. Of course I can, but I just don't want to. So the first thing I'll do here, I'm going to do npm run build and ask Vite to build my Vue.js application. And it does its things and eventually creates a dist folder, and in that dist folder there's the static files of my website. There's the index.html and the JavaScript and CSS that are required. Now let's go ahead and configure our node.js server to serve these files. So I'm going to say over here app use express static, and I'm going to serve the files from the process cwd plus dist. So it's going to go to this dist folder over here and get the files from there. Let's check it out. I'm going to go to localhost 3002 and I get my website. Now let's play with this HTML. Let's add here an h1 this works, save it, refresh, and we see it here. So we know that that's working. Another thing I need to do when I prepare to deployment is remove secrets from my code. If we take a look at our API TS definition, we have the connection string hard-coded over here, and that's a vulnerability. In real life, we're going to get it from an environment variable. So let's go ahead and do that. Process env database URL. So this tells the code to first search for this key in our environment variables and use that as our database URL. Let's do also the same for our session secret. So I'm going to take this secret and say also process env session secret. And I'm also going to say that my port comes from an environment variable because that's very common on cloud providers. And the last thing I'm going to do here is I'm going to add a start script to my package.json that will know how to start my app. So it's going to run tsx source server. We don't need the watch in this case because we don't need the hot reload and listening to changes. It just doesn't matter anymore. Cool. So we are almost ready for deployment, and we're going to take this website and deploy it to railway.app. They have a very nice free tier and you can deploy it all for free. Of course, you can also deploy to Heroku or to Vercel or pretty much anywhere else. So let's go ahead and deploy this to Railway. So the first thing I'm going to do here, I'm going to say Railway init. And I'm going to get Railway to give my app a name, whatever it chooses. And then I'm going to click this URL and it will open in the browser and we can see this dashboard for my app on the browser. So the first thing I'll do over here, I'm going to add a database and a PostgreSQL database. And I'm also going to ask my code over here, Railway app, to upload my source code to Railway. And as that happens, I can do some more configurations over here. The first thing I want to configure is to have a domain generated because I want to have a URL to touch this website. So it created the URL for me. And on my variables, I can start adding variables. The first one that I want is the session secret. So new variable, session secret, and I'm going to set it to some UUID generated value from here. And next, I'm also add a new variable, which is a reference to the database URL as we talked about earlier. Now, what actually happens here is that when we push the code to Railway, Railway takes the code, runs npm install, npm run build, and npm run start to start our code. And we can see here the deployments code, and we can see it working, and we'll later be able to see its logs. And let's take this time to talk a little bit more about what you can do with Remult. So we obviously didn't have time to show you everything here, but Remult fully supports GraphQL and OpenAI. It has great entity lifecycle hooks so you can intervene before and after you save a row or delete a row. There's entity relations between many to one and more. There's backend only updated fields, backend only visible fields. You can have backend computed fields. If you like decorators, that's great. If you don't like decorators, we have a way to do things without decorators, and we even support plain JS and JS docs. So let's go back to our Railway website, which is still building. We can view the logs over here and see it progress. And we can look at the deploy logs and we see something very similar to what we've seen earlier in the terminal tab of VS Code. We see how the table was created. So let's go to this URL, and now it's working. Let's sign in as Jane and add a very important task. And let's open it in another browser to see that the live query works also in production. Yay! And we can even go to a Railway and ask it to show us the database. And we can see the data here and the task table here. And we can set it to true, and we'll count to 5, 3, 4, 5, and it will show here true. Yay! So all of this updates and all of this works. That's it. I hope you like this tutorial on how to create a full stack app from zero to deployment. You are welcome to visit our website, remult.dev, where you'll find great tutorials for React, Angular, Vue, and Next.js. And of course, I invite you to come over to our GitHub repo, and which is right over here, and give Remult a star, and join our Discord. Be active, open issues, use it, do things with it, and let us know if you're having fun. Thank you so much. I hope you enjoyed this, and see you in the next video.